8.3, we are still talking about inference. So we're still talking about hypothesis testing. We're still talking about finding a p-value, area under a tail. We are still talking about means. So that means we're going to have a value for a mean, an average. We're going to have standard deviations. But this time we're talking about two samples, or more specifically, the difference between the means of two samples. And we've done this before. We did this back in module 7.3. And you may remember some of this information. Remember where we had dependent and independent samples? And most of our examples were independent samples. And so we did an example. And again, you'll notice these are kind of the same examples as to whether something is independent or whether something is dependent. So you've seen this before. If you're reading this material and it feels like deja vu, it is, because you've seen this before in 7.3. It very closely mirrors it. But here's where it changes. Here's where it changes, because now we're looking for a target and we're finding the area under the tail rather than the confidence interval. So we are going to take our sample, our difference from our samples, and we are going to establish that the null hypothesis, and this is kind of important, the null is that there is no difference between these two. So if you had data set number 1 and data set number 2, and you found the mean of this data set, maybe say it's 86, and you found the mean of this data set, the null hypothesis is that these data sets have the same mean, that there's no difference. That is the null. That's the king of the mountain at this point. Our alternative hypothesis is going to be, no, wait a minute. There is a difference between these two. Maybe this is an 84%, but our alternative is going to be, there is a difference between them. Either it's negative, a negative value, a positive value, or we're not sure if it's negative or positive, but we just know that they're not equal to each other. Let me take a minute to tease apart this positive and negative. We alluded to this a little bit earlier last time when we were talking about some of the story problems where it was difference in proportion. Remember, we had something like the number of people in Texas, or the proportion of people in Texas minus the proportion of people in New York, right? It was something like this. And we said, if Texas was the larger number and New York was the smaller number, then when you subtracted them, you ended up with a positive value. 8 minus 3 is positive 5. That would be like this situation right here, where the difference between the two is a positive number. On the other hand, if Texas was a smaller number and New York was the larger number, you would get a negative value as your answer. 3 minus 8 is negative 5. Now that negative just means that New York, the second number, had a larger mean in this situation. And that's what this represents. It represents a situation where the difference between the two is a negative number, which just means that the second item had a larger mean. So when you subtracted them, you get a negative number. So I just wanted to explain that a little bit, because sometimes students are like, is it negative? Is it positive? Blah, blah. And then this directly relates to the areas that you're finding. If your null hypothesis is right here at 0, and you think that it's a positive value, this is the green, this is the area you're going to be finding. On the other hand, if it's a negative value, you're going to be looking for this area to the left. So it does make a difference whether you say positive or negative. Here is data set number 1. This is the weight before the diet. And here's data set number 2. This is the weight after the diet. And remember, our null is that the difference between these two is 0, that nobody lost any weight. That's the null hypothesis. And so if we had a normal distribution, that would be 0. Now our alternative hypothesis is going to be that people lost weight, indicated by the negative sign. If they gained weight, then they would be a plus value, right? Because you subtract them. And so our alternative hypothesis is going to be over here somewhere. It's going to be a negative number. And because of that, we know we're looking for the area to the left. We're looking for this area. This is going to be the p-value we're going to use to compare to our significance level. And our significance level is 5%. So if that p-value comes in below 5%, good for us. So here we go. Here is all the information that we just explained. Here's a histogram of the data if you wanted it. Here is the mean of the difference. Here's the standard deviation. Here is man, look at that. Holy cow. So again, our null is at 0, and this value, this 21.5, negative 21.5, that is the mean of our alternative. And this is the mean of our null. And that alternative mean is 16.779 standard deviations. Holy, this is really not close. This is beyond Pluto. This is beyond the Oort cloud. This is all the way over to the next galaxy, man. This is so far. This is not even close. And we're going to try to find this little tiny area underneath there. And this is actually what it shakes out to be. And so clearly we're going to be well below that threshold, not even close. So clearly this is going to be a very small number when we compare it to our threshold of 5%. I think that's what we were looking at, 5%. Yep, right here. That's our threshold, clearly well below it. So that means we get to reject the null. So that means that the difference of 0 gets pushed off the mountain and we replace it with our value. And so that is a good example of dependent situations. We also have independent situations. And when you have independent samples, that means you may have different n values, different number of items in each set. And so in this particular example, what we're looking at is the cholesterol level of individuals immediately after they had a heart attack. So that's group number 1. So group number 1, someone had a heart attack. They went to the hospital. They were stabilized. And after being stabilized, a blood draw was done and they measured their cholesterol level. And then you have a second group of people whose cholesterol level was just measured at their annual physical exam. So you go in to see your doctor for your physical, they draw some blood, they measure the cholesterol level. And what we're asking is there a difference between these two? Is the cholesterol level of someone who just had a heart attack different than the cholesterol level of a healthy individual going in for a routine checkup? Now, the null hypothesis is there's no difference. The cholesterol levels, the average, should be exactly the same. That's the null hypothesis. Our alternative hypothesis is no. We think there is a difference between these two cholesterol levels, between the cholesterol level of these two groups. We take group number 1, which has 28 people in it. That is the sample size. We find the mean, we find the standard deviation. We take group number 2, which has 30 individuals in it. We find the mean and the standard deviation. Now, really quick, looking at the mean, it looks like those that just had a heart attack have an elevated cholesterol level, but we're not sure yet. We've got to say this with a certain confidence level, right? A certain significance level upon which we're going to challenge. So Google Sheets does all of the calculations for you. It finds the value for A, the value for B, the degrees of freedom. It plugs all of these values in to find the test statistic. And then upon finding the test statistic, it finds the area under the tails. So once again, if we go back up here, and I'm going to scoot over just a little bit here. Boop. If we were to draw this example, our null hypothesis is that there is no difference between the two of them. That is the null. And remember, this is mu1 minus mu2. That's what we're looking for, that there's no difference between them. That is our null hypothesis. We believe that the alternative hypothesis is greater than 0. Greater than 0. That means we are looking for the area above to the right of our target. We are going to find this p-value, and we are going to compare that to 1%. So is this area, is that p-value less than 1%? If it is, that's good for us. If it's not, then that's bad for us. And so we go through and we do all the calculations, and this is our p-value, an extremely small value for p. which means we get to reject the null hypothesis, which means we can replace it with our alternative, which means there is a difference in measurement that is greater than 0, which means there is enough evidence to show that patients who have had a heart attack have higher cholesterol on average than healthy people that come in for a physical checkup. So we are testing the claim that the average GPA of night students is different than the average GPA of day students. So what is different mean? Is different means not equal to, not greater than, not less than, just it's different. We don't know if it's greater than or less than. We just think that it's different. So the null hypothesis is that the mean of this first sample is equal to the mean of the second sample. Mu sub 1 is equal to mu sub 2, that there's no difference between the two values. The mean of the evening is the same as the mean of the day students. That's the null. There's no difference between them. That's the null. Our alternative is, no, we think there's something going on here. We're not sure if it's greater than, we're not sure if it's less than, but we think there's something going on. So our alternative is mu sub 1 is not equal to mu sub 2. We think that there's a difference. Now, if instead of is different, if they said is less than, then you would change this to the less than symbol. Or if they said is greater than, you would change this to the greater than symbol. But because they said is different, that means we have to use the not equal to symbol. So this is a two-tailed situation. So this is how we set it up. And again, we're using mu's. We're not using the X bars. We're just using mu's. Okay, so let me get rid of the old data from a previous problem. And let's have a go at this one. So group number 1 is going to be the evening students. So there are 30 evening students. That's our sample size. Their GPA is 2.32, and the standard deviation is 0.69. That's group number 1. Now for the daytime students, the students that took classes during the day. There were 45 in our sample. Of those 45, the average GPA was 2.62, and the standard deviation is 0.87. So right away, looking up here, you can see that the difference between them, if you subtract them down here in row 14, see the difference of the means? 0.3. So the evening students, group number 1, has a lower GPA, but maybe that's because we happen to pick 30 students in the evening classes that are the bottom 30 students. And maybe the 45 students that we picked in the daytime were the top students. And we're comparing the bottom of one group to the top of another group. Maybe that's what's happening. We don't know, because we've got to go in and do a deeper dive on this. We got to look at the standard deviations, and we got to do all of these calculations. Our significance level is 1%, 0.01. There we go. So here's our confidence level. Here is A and B and our degrees of freedom and our critical test statistic. Our null is that there is no difference. Mu1 minus mu2 is 0. This is our null hypothesis. Our alternative hypothesis is that there is some difference between them. And we found that there is actually a difference. It's over here at negative 0.3. This is our alternative hypothesis, the difference in those two means. That's why we got row 14, the difference of the means. That's our target. And now we are looking for the area to the left of this target and the corresponding symmetrical area to the right of this target, which actually would be positive 0.3. And why are we looking at the two areas? Because this is a not equal to situation. So it's a two-tailed situation. We got to look at both of them. If it was just less than, we would be looking at this area. If it was just greater than, we'd be looking at just this area. If these two p-values come in less than 1%, 1% is our threshold. So if these two areas come in below 1%, that is good for us. That means we get to reject the null hypothesis and say that there is a difference between the two. If these areas come in above 1%, that's bad for us. We fail to reject the null, and we can't push the king off the mountain. Here is the area below 5%, not looking good. There is the area between the two. Copy, paste. Here is our test statistic. Copy, paste. So our test statistic came in at that many standard deviations below the mean. This is our p-value. We came in at 10%. Sorry, everybody. We came in at 10%. That means not good. That means that we failed to reject the null. The null remains king of the mountain, and that there is no difference in GPA between evening students and daytime students. All right, so the correct decision is we failed to reject the null hypothesis. The correct summary would be that there is not enough evidence. There we go. A researcher takes samples of Fahrenheit from 15 days in Detroit and 13 days in Seattle. Use the sample data from the table. Got it. So I'm going to highlight this data set, and I'm just going to open up a new spreadsheet. So new spreadsheet, and I'm going to paste that data right in the spreadsheet. There it is, Detroit and Seattle. What do I want from both of these? I need the mean and I need the standard deviation. So we're going to say equals average of Detroit. There's the average of Detroit. And here's the standard deviation, STDEV of Detroit. So there it is. And I'm just going to drag these across to get the exact same values for Seattle. So here's what, 126 degrees Fahrenheit in Seattle? I don't know. I'm a little skeptical on some of these numbers, but it is what it is. These are the data that we're given us. Really, Seattle's that much warmer? Nah, I don't think so. So anyway, here's the data from Seattle. Here's the data from Detroit. We've got the mean and the standard deviation from both. Clearly, there appears to be a difference between the two. Seattle is apparently in the tropics someplace because their average temperature is 97. Test the claim that the mean temperature in Detroit is less than the mean temperature in Seattle. So looking at the numbers, you could say, well, yeah, look at it's 79 and the other one's 96. But again, maybe we just had an awkward sample of data from Detroit where it was abnormally cold and an awkward sample from Seattle where it was abnormally warm, right? Maybe that's what happened. We don't know. We got to run through the numbers. And so let's do that. So I'm going to kick this over here so it's a little bit easier to run these numbers. Let's do this. Boop, boop, get rid of that. Okay, sample one is Detroit. So my sample size is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 in Detroit. And while we're there, we'll just do the 13 in Seattle. Okay, now the mean of Detroit, I'm going to copy this value and I'm going to paste it special value only. And I'm going to take the standard deviation from Detroit. I'm going to copy it. I'm going to paste special value only. Okay, that keeps the formatting of everything like the yellow cells and all that good stuff. Okay, now let's go to Seattle. We're going to copy the Seattle data, paste special value only, copy the standard deviation, paste special value only. And now our significance level from the problem itself is 1%, 0.01. So again, to make sure that we're certain what we're doing, the idea here is that the null hypothesis is that there is no difference between the Detroit and Seattle mean temperature. This is our null, that there's no difference between them. On the other hand, we're saying, no. We think there is a difference, and we think that the Detroit is less than. And then when we look at the difference in the means, we get negative 17.2 degrees. This is from our sample, the mean of Detroit minus the mean of Seattle. This is our alternative hypothesis. And we believe that it's less than, so we are looking for this area, this p-value. If this area comes in compared to 1%, right? That's our significance level. If this comes in below 1%, if this p-value, if this area is less than 1%, that puts a smile on our face. We get to reject the null that they are equal. On the other hand, if this p-value comes in above 1%, we fail to reject the null and there is not enough evidence to show that there's a difference in temperature. Those are our two options. So what does the data show? Here is the area below our target. That is an extremely small area. This p-value is 0.0001739. That means that we get to reject the null hypothesis and replace it with our alternative hypothesis, which is that Detroit is colder than Seattle. The alternative hypothesis is that this is less than 0. Our test statistic is this number right here, which is negative, which is good. And that's a good sign, right? Because we say less than 0. Our p-value is this value right here, which again is good. That's a very small p-value. So that means our p-value is less than alpha, which means we get to reject the null hypothesis. So the correct summary would be the blank, the claim that the temperature in Detroit is less than the mean. There is sufficient evidence to support the claim that the mean temperature in Detroit is less than the mean temperature in Seattle. Let's see how we did. I think we did okay.